do something of interest or value to you. The second setup that I have is something called T-File. And in T-File, we have to have variables to access an open daylight. So if you'd rather work on open daylight than on the Cisco environment, this is just an alternate environment. We're probably going to want to use one or the other for the majority of the hackathon. Progress, that's outbreaks, the right road, so it'll be up to you on both of these. Yes. We'll try some things out there, and then we'll choose whichever ones are more interesting. You guys, we got good ones. Any questions? Okay. Okay. So, yes. A little louder. Okay. It's a tough battle. Okay. So, software-defined networking. The idea about software-defined networking, when it first, the whole idea of software-defined networking first came about, the idea was we wanted to separate the control plane, right, the real brains of the router, the part that decides what to do with packets, to separate that from the data, the thing that's actually forwarding the packets. So if you separate those, the idea is you can take something, a complex piece of an appliance, like a router or a switch, a physical piece of hardware, and put the configuration and control of it, centralize that in one place, and then have the data point, the different parts that are actually forwarding all the packets, have that distributed. That would allow you to use much just off-the-shelf hardware, rather than having to use custom hardware and custom ASICs. That was really one of the goals of software-defined networking. At the same time that was coming about, a new protocol was defined called OpenFlow. How many of you have heard of OpenFlow? Well, OpenFlow is a very, very basic, I would say, networking protocol for forwarding packets. And the idea is that the control plane, which you've separated out and made centralized, it can just write some very simple rules to the data plane. And then the data plane, and the way it communicates with it is using OpenFlow. And then the data plane can do all your control. That was kind of the goal of the software-defined networking. That's where it started. Fortunately, it's grown way beyond that. And now when I talk about software-defined networking, what I think is really valuable is when you look at all the information that the network has. The network knows about all the flows, all of the packets, all the decisions it's making, all the connections. If you imagine it, now you can access that information programmatically. To me, that's really where the power of software-defined networking comes. And that's what we're going to look at today. And that's what we'll spend the majority of our time. Not so much the basic concepts around OpenFlow, but really what we can do is now networks are programming. This is basically the same concept that I just described, the tracking. So there's this basic separation of the control plane and the data forwarding plane. But the key thing here are the arrows that you can see on the left-hand side. The idea is we want to be able to take that information that's down deep in the network in the transport layer. We want to expose that information. This is harvest network intelligence. We want to work that information up, make it available to applications that you can write. Access the information from the network. You can make some intelligent decisions based on that information. You can reprogram the network based on that information. And that's what you see on the right. That's really the power. That's what we're trying to get to. And that's what I mean when I talk about that programmability. So, oops. In order for that to work, what do we really need then from our network? What do we need from the software defined network control if we want to be able to have this? interfaces that are easy for us to use, that give us access to information we need. How many of you have tried writing a script, like using it spec or something like that, to configure a router? Have any of you ever done that? It's actually very difficult because the configuration of the router is all text-based. So you have to do some fancy things with regular expressions, pattern matching, and then as soon as you change the way the router works, the way CLI works, all of your scripts are broken. The idea with these programmable interfaces is they're written with software in mind, so they're much more structured, they're much more formal, so they make it a lot easier for you to write code. Because it's the same things in the CLI that are before, but it is much more structured and much more consistent. Okay, Open Daylight. So what Open Daylight is, it's an open source platform for software-defined networking and for network programmability in general. What you see in the middle here are all core services that you would typically expect from that. But what I want to point out is that on top of all those core services, Open Daylight provides these application programmable interfaces. And you see the words REST and RESTConf and NetConf up there in the green. That's the way that we'll be able to access it. I'll show you later on with hands-on exercises how using those protocols, interfaces, how you can access Open Daylight. And I'm going to skip through the rest of this in the interest of time. I won't talk too much more about Open Daylight. Instead, I'm going to get straight to the network programmability. So network programmability. One of the reasons why network programmability is so important is if you look at the cost of running a network. This could be a small network, like let's say you work at a small business and you're responsible for the network. Actually, how many of you are like IT people? How many of you run networks? You, okay, several of them, okay. So if you think about here, what the cost is of setting up and running your network, you probably need to buy some network equipment, right? And that can be expensive. I know the routers and switches, access points that my company at Cisco sells, they're pretty expensive. So that costs a fair amount of money. However, that's not the majority of the cost. The majority of the cost, because the cost of the equipment, that's what we call CapEx. That's a capital expenditure, right? That's the OpEx. That's actually what the majority of the time, the majority of the cost, the majority of all of you would probably be spending your time is to operate these networks. So the whole goal with network programmability is let's try to reduce those OpEx costs. Let's try to make it easier to program the network. Let's make it less error-prone. Instead of writing these difficult scripts that interface with the CLI, now use REST-based APIs and programs to interface with them. That's the whole idea. And that's really what the big motivation for network programmability. How many of you have heard of SNMP? It stands for Simple Network Management Protocol. So that sounds like exactly what we need. It's meant to be simple and manages our, we can use it to manage our network. It was defined back in the 1990s. The problem is SNMP doesn't really work. How many of you use SNMP to configure networks today? Yeah. Probably no one. It's actually not very useful. It's good for pulling off statistics from your network. You can use it for like if a threshold crosses and getting an alert. It's good for that. You can't actually use it for configuration. So really there was a need for something better. And so that's what the network operators brought. IETF say, yeah, we agree. We need to do something better. So the agreement we came to was, well, let's take what we've learned from using these CLIs, the routers and switches. Let's take what we've learned from using SMT. Let's take what we've learned from operating networks, and let's come up with something better. What we came up with was these three things: netcom, presscom, and Yang. We're going to look at each of those. But basically, netcom and presscom are two protocols for network management, and Yang is a data modeling language for networks. So as I mentioned, Yang, that's a data modeling language. You could actually use it for other things, but it was designed specifically for modeling networks and network configuration. One of the important things with Yang and the way that we use it is we separate out configuration information from state. The configuration information is something that you would configure as an administrator, whereas the state is going to be real time. It's going to change based on the operation of the network and what's going on. So we separate those two out, and we give you access to those recommendations. Now, the other really important thing with Yang, though, is this part I mentioned before about being more formal. It's really a formal contract language for defining the network configuration. We use constraints so you can limit exactly what types of values are allowed. We have reusable types that we define. So it's sort of like a programming language. It can actually build up these simple concepts and reuse them across the project. And we'll look at some of that later on. The way Yang is defined, it starts with the top level grouping of a container, and that container is just a way of grouping things together based on containers. In that container, we can then have a list. And a list, you imagine, let's say you have a list of interfaces. I mean, just a router or switch has many interfaces. So you would have a list of interfaces, and then each of those interfaces would have some specific data elements associated with it, and those would be these leaf nodes. And so the leaf nodes actually have the end information of it. So this is an example of what a Yang model looks like. And I'm just using BI to access it. You can see at the top level we have a container. The Yang model I'm looking at here is called network topology. And you can see that contains a list. It contains a list of topologies. Each particular topology will have a topology ID. It will have a server. So each of these information, each of these bits of information will be associated with the topology. Now, fortunately, there are some better tools for looking at Yang models than text-based language. And we're looking at a couple of those today. One is called P-Yang. P-Yang is a command line tool. The idea with P-Yang is that you can have the P-Yang validate if a given Yang model is valid, syntax is correct, that's a valid Yang. You can also use it to display a tree-like format of what the Yang model looks like. I think I have an example. Yeah. Here's an example on the next page. So this is running that same exact Yang model, the network topology Yang model through P-Yang. And you can see what it gave me. It was basically, instead of a text file, it's now a tree. It just breaks out all of the elements of the Yang model. It makes it a little bit easier to understand. Another very handy tool is Yang Explorer, and we'll take a look at that today as well. The idea with Yang Explorer is that's the picture down here on the bottom right. The graphical user interface is basically a browser. collapse and expand different elements of the Yang. And that makes it much easier for you to work with the Yang model, to drill down into those parts that are important. I'm not going to go into this. We'll talk more about open daylight later. I don't want to spend too much time on that now. Instead, I want to finish covering off these three things. So we talked about Yang. Now we're going to talk about netcom and then expresscom. So netcom stands for network configuration protocol. It was defined within the IES. It was originally defined back in 2006 before we had Yang models. So when you're looking at Yang RFCs, the first one you might find is this 4741. That's actually the first version of netcom. There's a new version of netcom, an update to netcom that takes advantage of using Yang. And that is part of so, for the most part, whenever I talk about netcom now, we're using it today and tomorrow at Hackathon, we'll be using the 6241, RFC 6241 is the version of netcom to be used. So, the idea with netcom is that netcom provides us the operations, the actual protocol that we need to talk to a network device. The information that we send and that we receive back from the device, that's encoded using Yang. So Yang, think of Yang as sort of being like whatever you, what netcom is providing you is the actual command. So for example, you could do a get, or you could do get configuration. So you're requesting the configuration of the device. And the device then does configuration. What it's going to give you is an XML representation of this configuration. That XML will be encoded based on Yang. So Yang is actually the information that's transported back and forth. Whereas netcom is actually the actual command line for interoperability. The way netcom works is usually over SSH, so it's encrypted, right? You can also use it over TLS. The idea is that you have a low exchange. So if you think of when you're using netcom, you typically use like a network administrator. If you're actually the netcom client, you establish a connection to, say, a router or a switch. The router or switch is acting as the netcom server. You connect to it via SSH, you have to give it your credentials. Then there's basically this hello exchange that happens. What that hello exchange does is it tells you all of the Yang models that the device supports. That way you know how you can interact with it. Once that happens, then you have your network session, and it goes into the duration, so the time that you email, and you're able to interact with the device. When you're done, you just close that project.
I hope so.
Now the operations that you use within netcom, I mentioned get and replace before. Those are for retrieving information from the device. We also have edit config, where you can change the configuration. We have copy config. The idea with copy config is you want to be able to, you can imagine you might want to get the config, make a copy of it, make some changes to that copy, and then later on commit that config by doing an edit config with the new configuration. That's one of the really nice things that I didn't point out about netcom before. That I should have mentioned is that the nice, really key thing, that one of the key things that netcom gives us is the ability to make multiple changes and then do them all as a single transaction. That way you don't imagine that when we were programming a router or switch or making changes in our network, we actually need to be able to make several changes, right? And then use them all as a group, use them all together at one time. That's what NetConf does. Without NetConf, with something like say SCP, all you can like change the whole idea of transaction consists of multiple changes. That's a key thing that NetConf brings to us. Okay, so that was NetConf. So the idea with RESTConf is that I'd say if you look at the way that a lot of programmers are working today, if you look at their web-based applications, they tend to use what are called REST-based APIs. There are things like get, put, post, patch, all these RESTful verbs that you see using HTTP. That's what a lot of programmers today are used to. So the idea with RESTConf was we want to make network configuration more accessible to more people. NetConf is really handy, but it's kind of more of a machine-to-machine interface. If we want to make it easier for people to communicate with the network, we want to make something lighter weight. We want something with RESTful APIs. That's basically what RESTConf is. So the idea with that is instead of using SSH or TLS, we use HTTPS to establish the connection. And instead of using XML to encode the information, you have the ability to use JSON. And JSON is a format that many web developers are very comfortable with today. So the whole idea here is to take all of those same capabilities, or at least the core set of them that we have in NetConf, and to make them available via REST-based APIs. And that's really what RESTConf provides. So to give you an example of how this would work, on the left-hand side, I have that network topology Yang model that we looked at earlier. And on the right-hand side, I have a REST-based URL that I would need to construct. And the way I constructed this URL, this HTTP request, is derived from the Yang model. So I'll show you how the mapping would work. Basically, the very first part is whatever my server is. So let's imagine I'm accessing an Open Daylight instance. So if I had Open Daylight running on my laptop, it'd actually be running at localhost 8181. That's the first part. The next part is I'm using RESTConf, so I add that to my URL. Network topology, you can see that comes from the model domain of the Yang model. The second network topology, that's because within the Yang model, you can see I'm accessing the network topology container element within it. Then, I mentioned before, within Yang, you have two different things. You have configuration data, and you have operational data. In this case, I'm accessing the configuration data. And the way I can tell it's configuration is because if you look at where I lit up in blue up there, I'll toggle it. It says RW. That means that it's a read-write element. Configuration is always read-write. Whereas if you look further down at the server-provided field, you can see it's RO, meaning it's read-only. So if it's a read-only element, it would be operational. If it's a read-write element, then it's configuration. And the rest of the URL gets defined exactly the same. You can see what I'm doing is I'm walking down, I'm pulling information from the Yang model and just putting it into my URL. So eventually I have my URL for my REST request. And then what you see in the middle here, the information that's in this case encoded in XML, in this case is actually coming from another Yang model. As I mentioned before, Yang is it's very modular. So it's not like when you look at a router or a switch, all the information won't be in a single Yang model. It'll actually be spread across a set of Yang models, which is a little complicated on the one hand, but it makes the information much more modular, much more reusable. Okay, a couple more things to get through, and then we'll actually take a short break and have more time for questions. So, important thing that I wanted to point out, I talked about Yang, but I also talked about netconf and restconf. Right? And netconf and restconf are ways that we're going to operate on or use the Yang data models. And it's a little hard to read this on this projector, but if you download the slides, the picture will be a little bit easier to read. The idea is that you don't need to choose one or the other. Netconf and restconf are actually use them in combination. You could have one program running that shows your netconf, and you could be writing something else in restconf. They could both be operating on the same network device at the same time. They'll both be accessing the same configuration database, the same data stores on the network device. So it's just two different protocols that you can use to do the same things depending on your needs. The key thing is they all operate on the same data models as defined by the Yang models. Let's see. I don't think we need to go into this one. But the idea here is that, we'll come back to that later. Okay. So the next several slides cover some hands-on exercises, but before we dive into any of that, Kevin mentioned to me that they actually have the tea break going on outside, so you're welcome to go out and enjoy that. I think it's about like a 15-minute break. We'll take it. It's back up at about 11:15. Does anyone have any questions, though? I know I covered a lot of material there quite quickly. Yes? The role of iOS, like you're talking about like Cisco iOS. Okay, so typically within SDN, or let me take more of an example of say restconf or netconf. The iOS device would typically be the netconf server or the restconf server. So if I go back to this, let me go back to my restconf example. Yeah, so you can see here, iOS will be running on this router, right? On the left-hand side, and it will actually be acting as the netconf server. So now the network administrator or Open Daylight or something like that would actually be the netconf client, which would connect to the router and establish this netconf session. And the configuration of the router or switch would be represented as a set of Yang models that are supported by the netconf server of the rest of us. So for those of you who couldn't hear that, the question was the defaults on network equipment, Cisco network equipment. Does it support the more recent versions of the software? Do you support netconf? If you're looking at iOS XR, for example, you need to have at least version 6.12. We're already well beyond 6.12, but I think 6.12 was the first one that really had a very stable and OXP device, so we'll be able to see what version of software is required for that. Do you have some iOS devices, and if so, are they XE or XR? It's been a few years now that it's been supported, so you might have to upgrade if you haven't upgraded your for a while, but it's basically one across all the It only be something very old that would for upgraded. Any other questions? Yes, I tried to keep it very short since I think it's hard for people to hear. But after this, I have some hands-on exercises we can go into, and we'll see how people do with those. I guess I should even ask at the beginning how many people came just for this versus if they've been here all year. Do you have a good idea? Good sense?